In the modules, you can also see that we have another page that I've updated today, if we ever get down there, for exam number 4 and your final exam expectations. So I updated that this morning. And so if you click on it, you can see I've tried to put in the information about when your exams are going to be, what materials you guys want to start collecting for it. And I'm going to start putting like together your topics and your practice problems. So it will all kind of get linked into here. So we're trying to keep this updated. So our first exam is going to be next Monday. It's going to be your ACS exam. It's all multiple choice. It's a little bit shorter. It's a 1 hour and 50 minutes. And there's going to be 65 questions, right? So it's all multiple choice. It's a little bit different feel of an exam, I would say. It's much more about you need to know the material and then you can get your answer pretty quickly. There's less of these like very large problem solving type of situations. So there's not a whole bunch of different calculations that you need to do. It's more about trying to get your questions set up correctly, a little bit of conceptual type of stuff. There is some math involved, but there's not tons of math. So you're not going to be solving a whole bunch of ICE tables. They do recommend a different equation sheet, which I've linked there. It kind of looks like this. You can see, so you just want to make sure that you kind of feel familiar with how they refer to things inside of this exam, because they use slightly different terminology, I would say, for some of them. And so you just want to feel comfortable with that. I went through the exam questions and it feels pretty straightforward. But I just feel like it's always nice to see this. You can start to get a little bit of a feel for it. And then these are the values that they recommend that you use for your molar masses. In all reality, since it's multiple choice, those different changes from their periodic table and our periodic table isn't going to be enough to change things. But if you want to get right on numbers, then you want to make sure that you're using their constants and their periodic table, though we generally have the same ones. This is kind of the big topics that they cover. And there is an online study guide that's available here. If you go to the ACS one, they have some practice exams you can do. If you purchase that book, I'm just going to see if I can find mine, that is still current for this online copy, the same as the in-person lab. I don't have it on me right now, but it's a green ACS study guide. So if you bought that at the beginning of the semester, then that's going to be the same. There's also ACS writes the high school chemistry Olympiad exams. So what that is the chemistry Olympiad is kind of like a competition of high school chemists. And so they give you these different quizzes, and then as a team, you guys compete. There's 3 sections to it. One is like a lab part. There's another part where it's like written questions, kind of like the free response questions. And then the first part is all the multiple choice. So if you want, you can click on this link and you can see their past Olympiad exams. It doesn't exactly cover the material for our class because it covers the entire year. So it includes some Chem 120 stuff. And it goes a little bit beyond our class in that it talks about like carbohydrates and that type of linking stuff. But if you want to see some practice problems, you don't want to pay for a study guide, that would be your best bet for it. You can see that when you click them, they have the same type of equation sheet. They have a whole bunch of different practice problems. And then they also have an answer key, so you can see how you did. What I would recommend for these is generally your first third is a lot of Chem 120 stuff. So it's not bad if you want the review for Chem 120, but if you want to get more into like what our class is, normally I start kind of around the 20s and look past from there. And that's where I've seen most of our the stuff for our class show up. They have, like for the local exams, they go back 20 years. For the national ones, they also go back 20 years. So if you need some practice problems, that is a great place to do them. You'll see that in today's worksheet, all of these ones, like these ones from 55 and 57, those are from these Olympiad practice problems. So I just went through them. I found some questions that were on the organic part. things that I thought were interesting or important, and then we put those together there. A cumulative exam, the final exam, that's going to be next Wednesday. It's going to be longer. It's about 2 hours and 45 minutes. You will be able to use a note card, right? So I would recommend that you prepare a note card. It's a 3" by 5" note card, handwritten, front and back is fine. I would definitely encourage you to make a note card in the sense that we've learned a lot of material, and so you want to start to like consolidate that into one simple place. Your note card shouldn't really be full of equations since you already have your equation sheet, which has a lot of them. You still get those like the metal ligands and the naming stuff that you've kind of been getting from the quizzes and the exams for chapter 23, so you don't need to include those, as well as like the color wavelengths chart. But if there's like other specific ones, like equations that you want, you can do that. If you just want to write down some notes about how you do naming, things like that, you want to write, show out your samples of your functional groups, right? Those are all good things to have on your note card. I encourage you to handwrite it because it's a good way for you guys to start to process some of this information to do that review. Because having to handwrite it encourages you guys to copy it again, right? Where if you just copy and paste it, you don't really retain as much. And then the second part is having you prepare a note card, A, makes it easier for you to find it, and B, it helps you identify either your weak points or what's important, right? And so that's what I'm trying to encourage you guys to do with that part. And so that's why we're trying to start to prepare them. Once again, it's an honor system, right? So it is a little bit on you guys and having that academic integrity, but it's definitely something I would recommend starting to put together. And to help you out with that, I made a study guide for each of our chapters. And so what I did was I pulled all of those different announcements for the different expectations for each of the chapters, and I put them all together into one, right? So we have chapter 13, 14, 15, 16, 17, 18. And so I broke it down by your chapters, 20, I think I have 22 at the end. So I'll move that up and then re-upload it. And so that way you can use your book to go through that. If there's a specific chapter that you're struggling with, I would recommend that looking at our worksheets that we were doing in class, right, is a good one to start with. And then after that, in your books, there's problems at the very end of the chapter, and there's also answers to those problems. And so that's a good place to get them. If you reopen your homework exams for Connect, it's not going to change anything for you because I'm taking your best score. But it's a good way for some of them, if they are like algorithmic problems, you can get a new version of that same problem, and so you can solve those again. So that's another way to get some practice problems, and then you'll be able to get that guided solution and stuff if you get stuck during your review. Does anyone have any questions on that type of stuff before we get back to the worksheet? Okay. So on Wednesday, when we do the ACS review, we'll kind of go through and we'll hit a bunch of different questions. We'll try to practice a little bit about the timing of things because it's a faster type of test. And so we'll try to like rattle through some of these questions, and we'll get a sample of that today when we get into that worksheet, the ACS practice for today's worksheet. So since there's no questions, then I'm going to have you guys pull up this first one. And so let's go ahead and name this structure and then draw out their line diagram. Now I know you can't submit your line diagram in here, but then once you get your name, go ahead and type your name into the chat, and we'll use that as we kind of move forward. So we're looking at question number 1, part A. Let's go ahead and try to name that one. I'm going to turn off my video so that way I can start to write on my tablet. So for your homeworks, the homeworks have been open for late turn-in. However, they basically go down 10% a day. So if you're more than 10 days late, it's really not gonna give you many points to turn it in. I think it pretty much gives you none. And so that's the part with the homework. So if we had like been on top of that, then yeah, you could have been turning them in late, and then you would have gotten some of those points. But I'm not going to go back and reopen them at this point. I will be dropping though your lowest lab score and your lowest quiz score and replacing them with your average score for each of those sections. So your lowest quiz, or take that one out and replace it with those quizzes. Your lowest lab, you will get the average score of your labs. So we're looking for names, right, for this compound. And so make sure that you find your longest chain. You want to think about which one of these is going to be our longest chain. And then once you have your longest chain, you want to start to add on your parts. All right, so we got one answer in. We got 2-chloral-3-iodo-pentane.
I entered there and then.
So we're going to wait and see if anyone else verifies that. And so we're trying to look at our longest chain. Right now, we're saying that it's pentane, which would be 5. And then we want to think about our numbering, which side we should start from. Right? So I agree with you guys. It does look like it's 2-chloral-3-iodo-pentane. You can kind of see that like our longest chain is going to be over here, right? 1, 2, 3, 4, 5. We have a chlorine group, which is going to get listed first because it's alphabetical, right? C comes before I. So that's going to be on the second carbon, 2. And we know that we should be counting from this way because our substituents start on the second carbon here. If we start from the right going left, then that would be the third carbon there. And so we have 2, 3, because this is the second carbon, this is the third carbon. And so we have 2-chloral-3-iodo-pentane. Very good. And there's no double bonds, no triple bonds, and so that's how we know it ends in ane. If we wanted to see that structure, I need to make 5 carbons in a row. 1, 2, 3, 4, 5. I need one coming off the 2, and this one should be our chlorine. And then the one coming off here should be my iodine. And that's what our line structure would look like. Does anyone have any questions on that part? Okay, let's look at this next one. And so we're looking at this ring compound here. Now, when you look at this, you want to think about how you would go about naming this one. Because there's a couple interesting parts. We have rings, we have a double bond, we have these groups here. And so just like last time, once you feel like you have your answer, then go ahead and submit it to the chat. We'll verify and we'll see how we compare. Mhm. So it looks like we have our first answer in. And so there's just a couple things. You want to make sure you look at your formatting of your question, right? Or of your answer. So think about whether or not we should be using the decimals or if we use commas between those. And then if you have a question about numbering the cyclo ones, you can go ahead and put that in the chat and where you can go over that when we go over the answer. Good. So we have another verification with that. And so it looks like we're agreeing with each other. So just a couple things. One is when we're looking at this one, even though we have the longest carbon chain of 1, 2, 3, 4, 5, we're not going to use that when we do our name. We're going to use our ring structure to do the name. So that's why our base is going to be a butane, is because we have 4 carbons connected in a ring. So we call this a cyclobutane. And then you're right, we have a double bond in here, which is going to give us a butene. Right, so we have our cyclobutene. So what was your question about numbering the structures, Jasmine, for a cycle? So your substituents, you do want them to have the lowest number, but there's also certain ones that you kind of have to start with. Right? So when we look at this, we have 2 types of substituents or like functionals attached to it. We have a methyl, and then what do we call the double bond? An ene, right? So between those 2, one of them gets the lowest value. Right? Do you guys remember which one we should start with for getting our lowest value? Is it going to be the methyls or is it going to be the ene? So between those 2, our double bond is going to get the lowest value. We want that double bond to start with 1 if we can. And since this is a ring, we can kind of choose any of these carbons to start with. So if we start with this bottom left, we can see that this ene would be coming off carbon 1 going to carbon 2, right? So we can number it to the right. If we number it to the left, then that ene is going to be between number 3 to number 4. Right? So 1, 2, 3, 4, 1, 2, 3, 4. But this isn't our best carbon to start with. We could also start from this carbon here. Now, if we start from this carbon here, not only is our ene on carbon 1, but our methyl is on carbon 1. And so how you kind of judge where you should start your numbering is you want to look at first who gets to like priority about getting the lowest value. And then number 2 is there an option for us to get an even lower number of lowest number for our substituents? So if we had to choose between this carbon on the left and this carbon on the right, we should choose the one on the right because this methyl now becomes a 1 instead of if we chose the one on the left, that methyl would be a 2. Right? So you wouldn't want to start here and list it as cyclobutene, right? Carbon 1, and then have this be on number 2 and number 3, or 2 and number 4. We would rather start here and have it be a 1, 2, 3. So a 1, 3 dimethyl cyclobutene, and then we can have that 1 either coming before the cyclobutene, or you can have that 1 coming in between your cyclobut-1-E. So either one of those. So for me, when I do mine, you can see that I put my 1 in between to kind of show where that one is. But you could also have it in front of the 1-cyclobutene because we know that that 1 is going to that double bond. Both of those are fine. Does that kind of clarify that question about what you need to be doing for that one? It could be either one of those. You can either have the 1 in front, or you can have it coming right before the suffix. It's a preference thing. Normally people, if it's just got 1 suffix, they will put it in front. So 1-cyclobutene, it's easier to say than cyclobut-1-ene, right? So it's more of a preference thing. You can't go wrong with either one of those. The only problem with 1-cyclobutene would be if you also had another ending in there, like an aldehyde, and then you couldn't just have 1-cyclobutene all. You would have to edit those. But that's beyond what we need to be worried about. Let's go ahead and jump over into C. So we're going to go and look at this chain here and try to come up with our name. Now, I would definitely recommend trying to do your numbering on these carbons. You have a lot of different carbons here. You have a lot of different options about your chain lengths. So you want to make sure that you find the one that's a good combination for you. So you want to find that longest chain. Let me get this out of the way. So as you guys are working through that, I just want to know what backbone you're going to use, right? So what's your longest carbon chain? Go ahead and list that out before you start working on the full name. So how many carbons do you guys have in your backbone here? So we got 1 for 7. Did anyone find a longer chain? So we have 1 for 9. And how'd you get to 9, Stephen?
I'm looking at the carbon that's coming off number 2, the carbon chain that's coming off number 2, and then the one that's coming off, what was it, 6?
Very good, right? Because if we look, this one that's going straight across, that's going to be our 7-chain carbon, right? But you have an ethyl that's attached to carbon number 2, and you have an ethyl attached to carbon number 6, right? So it's actually longer if we start down here at the bottom left and go all the way to the top right. So if we start from this one as being carbon number 1, this becomes carbon 2, and this becomes carbon 3 with just a methyl sticking off of it. 4, 5, 6, 7, and then we go up again, 8, 9. Right, so 9 is going to be our longest one, so very good. So they're not always drawn out with the longest chain right in the middle. Now, it makes a lot of sense when they do it that way, but sometimes because you can have these different groupings attached to it, then you want to make sure that you're checking, because we're going to name it based off of a 9 backbone, not based off of the 7. So once you guys have your name, you can go ahead and put that into the chat and we'll compare those. So remember that if you have 4 methyl groups that you're trying to identify, you should have 4 numbers. Right? Every methyl needs to be indicated, because otherwise, if we just have it as 3, 5, 7, we don't know which one would have 2 of those methyls in it.
So I just need to add a 5 to it?
Yep. Very good. So if we pull this up. All right, let's get this. So if we're looking at our carbons here, right? This became our 1, 2, 3, 4, 5, 6, 7, 8. Oh, sorry, I missed one. 5, 6, 7, 8, 9. Now, it doesn't really matter whether we numbered from the left to the right or the right to the left, because they both started off the same, right? that our carbon 3 is going to be the first time that we have a connection. Right, so it didn't really matter which one we started with. And carbon 5 happens to be right in the middle, so it doesn't really change things, whether we go from left to right or right to left. So when something like that comes up, then I generally choose to go left to right. That's just my own personal preference. It doesn't matter. So we know that that means that nonane is going to be our kind of like a base that we're going to start from. And so now we want to add to that. And so we need to add this methyl group here and this one here, as well as this one and this one. So I'm adding in just methyls, so that means we don't have to worry about them being alphabetized. And because we're adding in 4 of them, then we need to say tetra. And so now we list what numbers they're attached to. And so that's where we got the 3 from that one being attached to number 3. We got 5, 5 for the 2 attached to carbon 5, and then 7. And so that's how we put together the name. So you're right, Stephen, in what you needed to do. Does anyone have any questions on that part?
Yeah. What about the methyl group and number 1 methyl group? You don't mention that.
So which one would be number 1 methyl group? Are you talking about the one that's this one here?
Yeah.
So that's part of our nonane.
Okay.
Right? That's part of the backbone, so we don't have to mention it as being a methyl because we've already included it in our 9. So you really almost never have your methyl shouldn't be attached to number 1 if it's just the methyl. Does that kind of make sense?
Right.
Yeah.
Okay.
Yeah. Any other questions?
Hey, can I ask you a quick question?
Mm-hmm.
So if see on that 8-9 with that CH2 CH3.
Mm-hmm.
So if you were to have a skeleton and then a double bond coming out of a C, but like
Okay.
you don't have the CH2, are you assuming that that's an ethyl group?
So you're saying that
Like if you
this
had
was a double bond here?
No. So say you had a skeleton, right? And
Mhm.
you had a skeleton like that, okay? And then let's go to point 2 on the left side.
Yep.
Point 2, do a double bond going up.
Oh, so I see what you're saying. You're
Yeah.
saying if this was like this and then you had a double bond here,
That's an ethyl group, right?
this isn't an ethyl. That is a double bonded carbon.
To what though?
So this would just be a
Like-
carbon connected to like 2, so this would be a CH2.
So how would you name that?
This would be a different functional. It would be like a methyl, but you basically would have this be an ene. So this would become your backbone.
Oh, so you'd have even if it wasn't not as long of a chain?
Well, so when it's not as long of a chain, that kind of gets shifted into other ones. And so it comes back to your priorities about where you need to list them. And so I think that it's going to just confuse people. So
Okay.
we can go over that later on,
All right.
but it's not going to be something that you have to worry about for us because we didn't cover like how you would name all of your side chains. Basically, if this was still your main chain and you had something like this going on, you would name this in a different process that we haven't learned yet.
Okay.
Yeah.
All right.
Okay. All right. So our next one is going to be, let's draw out this structure. And then we're going to try to add in those hydrogens. Right. And so this one I figure that we can do together because I feel like this is going to be, I'm not going to be able to check in on you guys to see how you're doing. So I figured that we might as well just do it all at once. Right. And so for this one, when you're trying to draw out this structure, I always recommend starting out with your biggest chain, right? So start off with your base. And so for us right now, which part is our base? Like what should we have as our foundation that we're going to attach everything to?
Are we doing part C still?
No,
drawing
no, we're on to number 2. So draw the structure with the 1-chloro, 3-iodo, 2-methyl, 5-propyl
Oh.
cyclohexane.
The cyclohexane.
Right, our cyclohexane is going to be our base. Very good. So cyclohexane. 1, 2, 3, 4, 5, 6. Right. You remember that anything with a ring is called cyclic, right? Because it's got a ring inside, like a cycle. And so from here, I generally always make this top carbon carbon number 1 for me. Since I'm the one drawing the structure, right? You can choose to start yours anywhere that you want it to. And so I always like to have the top of my clock be number 1, and then I go to my right when I do all my numbering. Right? I just find that a little bit easier for all of them. And so if this is going to be my number 1, what should we have attached to my number 1? When we look at our name, do we have a grouping attached to number 1? So propyl is not attached to number 1. Propyl is attached to number 5. So who's numbered at number 1?
Chloral.
Chloral. And so I add my chlorine here. And so now I'm going to go to my right-hand side. I'm going to number this 2, 3, 4, 5, and 6. And I can start to attach my other groups. So that means that 3 has to be what coming off of there?
Iota.
Iodo. And then we have what coming off of number 2?
Methyl.
Methyl, so CH3. And then what do we have coming off of number 5?
Propyl.
And so how many carbons does propyl need?
3.
3. So we have 1, 2, and 3. So we have our base structure, but what else do they want us to add to it? Because this one's a little bit different than usual. They are asking us for something else as well. They want us to add the hydrogens. Very good. So for each of these carbons, how many bonds should our carbon have? Right? So if we were to look at this carbon here, carbon number 1, how many bonds should it have connected to it? 4. And so if it's going to have 4, then we need to go in and we need to add in those missing hydrogens to it. So that first one, the one attached to the chlorine, is missing 1 hydrogen. Our methyl group is already filled. We don't have to worry about that. How many should I attach to this carbon down here? Carbon number 2. One. And so we can go in and we can basically start adding them in until each carbon is connected to 4 things. Right? So most of them are just connected to 2 hydrogens. Some of them are connected to one if they attach to one of the substituents. And then up here, we can add another one. That's what we're looking for. Does anyone have any questions on that part? So now that we have all of this, I'm going to add on another part to this. And what I'm going to ask you guys is, do we have any chiral centers? Now, does anyone remember how we can tell what a chiral center is? Or what chirality means?
No.
It's non-superimposable.
Non-superimposable. So if we were to flip it over, then we wouldn't be able to line them up. They wouldn't make a mirror image. Right? Now that would be hard with a molecule that's big, right? It's hard to draw it all across a mirror and then try to imagine that. And so we talk about chiral centers because we're going to focus on individual carbons. And so we can look at each of those individual carbons. So does anyone remember what we need for that individual carbon to be a chiral center?
Does it have to be symmetrical?
So it's
Equally
actually
bonded?
not going to be symmetrical. It's
Mhm.
going to be non-symmetrical. It's going to be asymmetrical.
Right.
Feel
We
that.
want it to be connected to 4 different things. So if it has a double bond, it can't be chiral, or it can't be a chiral center. Right? So we're looking for something that's connected to 4 different things, and that's going to be how we can kind of tell what our carbons are. So if we look at this carbon here, it's connected to a hydrogen, a chlorine, and then it's connected to 2 different kinds of carbons. Right? This carbon's connected to a methyl, this carbon's connected to hydrogens. And so this would be an example of a chiral center. This one would also count. Now, is there any other one that kind of looks like a chiral center? So this one here, does that look like it's a chiral? Right, this one that we just, oh, I'm going to do it in blue. This one that's circled in blue. Is that one connected to 4 unique things, or is it just connected to 4 things? Right? And so because they're not all different, we have 2 hydrogens there, then that blue one can't be chiral because it has 2 hydrogens. And so when we mirror it, that means that we could kind of line up a plane where they would look the same. But Kaylee's right, that number 3 is going to be an example of a chiral center because it's connected to 4 different things. You have a carbon here, a different type of carbon here, an iodine, and an H. All of our other ones are all non-chiral centers because they're connected to 2 things that look the same. Now, chirality is not a huge part in our class. It is a bigger part as you guys go forward. It's very important in biochemistry because your body, it's very interesting, but like some compounds, they have what we call a left-handed version and a right-handed version in some ways. And their left-handed version might be very good for us, and the right-handed version might be a poison, right? That's kind of how chirality can have a big impact on things. And so then the compounds have to be made in specific ways, so that way we only get one side of them, right? That we only always get the left-handed one, or we only always get the right-handed one. Right? But that's something that you guys will get into your organic chemistry. And so I just want to make sure that you feel a little bit comfortable with it. It does show up sometimes on your ACS exams. It's not going to be a huge part of your ACS exam, but it could show up. And so I just want you to have at least an idea of that. When you're looking for chiral centers, you're basically looking for something that makes them so they don't superimpose. And the best way to look for them is just look for a carbon connected to 4 different atoms. So for these next one, we're going to try to kind of rattle through a couple of these ACS practice problems, unless someone else has a question on something that they would like to go over. All right. So what I'm going to do is I'm going to set a timer, and we're going to try to kind of do a little bit of a time. So normally when I did the math, you should have about 90 seconds per question for your ACS one. I'm going to give you guys 2 minutes right now. I'll tell you when the 90 seconds is up, and then when the 2 minutes is up. And so we'll try to kind of rattle through a couple of these and see how we do. Right? When you guys get it, then you guys can go ahead and put your answer up in the poll. And we can try that. Does anyone have any questions before we get started? All right. So let's go ahead and start with this number 55. Which statement about the branched hydrocarbon is correct? And you can go ahead and begin. Now, if I launch this polling, does it block you guys from seeing the question?
No, you can move it.
Okay. So we're about a minute in. All right, and so that would be our 90-second mark. Now, so far, I haven't gotten the right answer yet. So just think about that. If you've already submitted your answer, you want to think about your options and what you chose. And so that's our 2 minutes. So if we were to go through this one, right? A lot of you guys are thinking A is correct. Right? And so its name is 4-methylhexane. And you got that because you went 1, 2, 3, 4, and you said there was a methyl across. Right? Now, what's the problem with 4-methylhexane?
It's closer to 3.
Right? If we numbered from the right to the left, then we would have 1, 2, 3 methylhexane, which would be the name that we should be using. So that was a problem with A. And so the other one that you guys said was D. And so this is if we were to add radical chlorination, so we're basically adding in CLs, that we would get 1-chloro 4-methylhexane. What this is kind of looking for is if we would have a double bond and we would be trying to do some addition, right, of our chlorines there. And so right now we don't have a double bond. So we're not going to be adding in this chlorine to the end, right? So it's not going to be our D. I'm glad that everyone knew that it wasn't primary hydrogens, or it doesn't have just 6 primary hydrogens. We got 3 here, 3 here, 3 here, so we got 9. And so our answer is actually B. This compound is going to be chiral. So which carbon do you guys think is chiral?
Is it because if you were to flip it and then move move it to the, so where the branch is the same direction now, that top carbon would now be on the bottom?
So it's not necessarily that if we were to move it that it would be branched, but if we look at that carbon here, right? So if this is carbon number 4, it's connected to CH3. On this side, it's connected to CH2CH3. Down at the bottom is connected to an H, and this one would be CH2CH2CH3.
So it's 4 different functional groups, so it has to be.
So it has 4 different groupings attached to it, right? So it's a little bit tricky, right? I just wanted you guys to see kind of what it means when they're looking for chirality, right? And so that's one way to kind of go through those options. Now, if it's not got a substituent attached to it, it can never be a chiral center, right? And so that's kind of how I knew that it had to be this carbon here in the middle, is because if it's any of these other ones, they all have more than one hydrogen attached to them, and so they can't be chiral. So if you ever get chirality as an option, you just have to look for a carbon where it only has one hydrogen at the most, and then you can evaluate that one. So it's a way to kind of quickly throw out the other one. Okay. We're going to try number 57. I'll go ahead and start the timer.
Is that little box supposed to pop up?
Oh, that's right. I should start my poll. All right, and that's our first 90 seconds. Yep. All right. Sorry, I'm not sure why it's not showing up, but let's go ahead and let's look at our compounds. So what's it mean for us to say that this is acyclic? How does that limit things for us?
Is it a circle? Is it like a cyclo compound?
So if it's acyclic, it means it's not a circle compound.
Oh, so it's a branched. It's like a long
So
one.
it's some type of branched, or you can do straight chains as well, right? And so right now, some of you guys have it listed as just 3 structures, right? Now, when you guys drew this out, is this just a normal alkane? If we're C5H10, is that a normal alkane? No, right? So what do we have to have in there? We have to have a double bond. So we can put that double bond on the front one, and that's always like the first one I start with. So that's 1. My second one, I can move that down there, 2. Now, do I get any more structures if I continue to move that double bond?
No.
No, right? If I move it over another one, oh, sorry. If I move it over, it really would be the same as it being attached to my second carbon. I would just have to number from the other side. So that's our first 2 structures. Now, after that, we have options with our branching. So I can take my pentane and I can break it up. And so I can add a methyl group there. So now I have a butane, and I can add my methyl group to number 2. And then I can move my double bond. So I can have it on the first one. I can have it on the second one. Right. But I can also have it on the third one over here. Now, why would that be different this time?
Because the chain has changed.
Because the chain has changed, right? So if I add on the third one, then we have a space for that. So that's where these 3 came from. Now, are there any other structures that I can make? Because one of you said that there was 6. And so I'm curious if I might have missed one so far.
Couldn't you stack 2 carbon groups on top of each other? Like
So
like
to take this one
and put it on
and kind of do it like this?
no on top of the other one. Or I guess that would be the same thing, right?
Right? So if we stack them on top of each other, right, then it's going to look the same as our base one.
Right.
What happens if we're connected like this? Is there any way that we can make a double bond?
No.
No. Right? Because if we make a double bond, then that carbon is going to have 5 bonds, and it's going to be too many. So does anyone else see a possible structure for our isomers? Because I have the answer as 5. And so I just wanted to make sure that I didn't miss one as I went through to get that one. And so that's kind of what you're looking for your isomers. So always check to see if whether it's a straight chain, sorry, not straight chain, whether it's an alkane or an alkene. And does anyone know the formula for how you tell between an alkane and an alkene? Between your carbon and your hydrogen ratios?
If there's missing hydrogen, then it would be an alkane.
right? And so how many hydrogens should we have if it's an alkane?
3, sorry.
Okay? So if you have your carbon with an N, this one is going to be 2N plus 2. Okay? And so this is how you have an alkane. If you're less than that, then that means that you have to have a double bond or a ring in there.
Okay, can you explain the? It's that
Right? So the
two carbons have 3 hydrogens and the rest have 2. All have 2 for an alkane, right?
yeah, but if they just give you the molecular formula like C5H10, you can know right away that this is not going to be an alkane because we don't have enough hydrogens. And you kind of can tell this because if it was, basically each carbon gets 2,
It would
and
be
then we have an extra 1 on each end.
right. It
And
would
so
be
that's where the plus 2
12.
comes from. Sorry, what was that?
It'd be H12.
It'd be H12.
So could you also be like, oh shit, sorry, what was it? Could you also be like since it's 5 carbons, like 2 of the carbons have to make up 6 and the other ones have to have 2 on them?
Yeah, you can also figure it out that way. It's the same formula.
Okay.
Okay. So let's look at our next question. We're going to skip the other one on isomers because we're running a little bit low on time. So I want you guys to try this one with the naming. And so let's go ahead and look at this one. What is the formula for ethyl propanoate? Right, that's 90 seconds right there. So it looks like we're kind of evenly spread throughout. I'm going to give you guys the last second to kind of tie this one in. So when we're looking at this name, what kind of functional group is going to be our main one for this ethyl propanoate?
Propane.
So
the
that's our longest chain, but what functional group is kind of giving us this unique type of name?
What is it called? The ether?
Ester.
Ester, sorry, Ester. That's the one. The one with the O and then the O minus.
Exactly. So for this one, we have an ester. And so what that looks like is, I'm going to go ahead and share this screen, is we should have a carbon here. We have a double bonded O and another O attached to it. Right? Now, does anyone remember what makes up esters?
Let me refresh my notes.
Like reduced carboxylic acids.
So one side is a carboxylic acid, right? You can kind of see that here, right? That looks like a carboxylic acid if this was an H over here. Right? And so that's one part. And so it's like we take a carboxylic acid, and then does anyone remember what we jam on to this other side?
Carbon group.
So it's going to be the carbon group, but it's going to come from an alcohol. All right. So the way that the naming goes is whoever gets the 8 is the carboxylic acid side. whoever gets the ethyl or the methyl or the propyl, that's going to be this alcohol side. So you can kind of see which side of the equation you should be on based on where those O's are. So when we kind of see this, this gets written as CO2. And so on this left-hand side of it, how many carbons are we looking for?
3.
3. And on the right-hand side, we're looking for 2 carbons.
Can you go back to the page?
Yep. So now when we're looking at our name, what we're looking for is 3 carbons before we hit the O's. So that's going to be A or C. D would kind of work, except we don't see that CO2, so it's not actually an ester here. Right? So it's either A or C. Now, between A or C, which one do you guys think it should be?
A.
A. So it should be A because we only want 2 after. The problem that we have with C is there's 3 of them there. So that wouldn't be an ethyl, that would be propyl-propanoate. And so with your esters, it's about the carboxylic acid side and the alcohol kind of coming together as you're looking for those.
So, wait, I have a question.
Mm-hmm.
So like on that one though, couldn't you also know because propane is 3 carbons and ethyl is 2 carbons, so there needs to just be 5 carbons, and since everything else has more than 5 carbons besides A, that it has to be A?
Yes, so you can also find it that way
You
because
knew
it'll
like
be
that.
5.
Okay.
Mm-hmm. Yeah, so that is a faster way to find it. Sometimes they might throw in a curveball if there was another one with 5, but yeah, this one worked out fine. Mm-hmm. I'm trying to think if there's any other good one to go through. Let's just do 56 as our last one. Let's see how we do with this one. And so we're trying to find the formula for this compound. So we're looking for kind of like the molecular formula CH. So we're about a minute in. Sorry, I forgot to relaunch the poll. All right, and that's our 90 seconds. So it looks like a lot of us are showing C, which is great, right? And so one of the first things to do is if you counted your carbons, we could have eliminated our first 2, A and B, right? Because we know that there's 14 carbons. So that's a great way to start. So if we look at our drawing, they are sharing some carbons. So it's not like it's 6, 6, and 6, right? So the first one we count is 6. Then we have 7, 8, 9, 10, 11, 12, 13, 14. And then from there, we had some double bonds. So you kind of have some options about how you could fill this in. You could go through and draw in your different hydrogens, and you could see how many you would have, right? So this would get 1, 2, 3, 4. Those get none. Right? You could do it that way. But we know that we have that formula, the CnH2n plus 2. And so if this was all straight chained, we would have had C14H30. Now, every time we add in a double bond or a ring, does anyone know how many hydrogens we eliminate? Right, so if we have propane, that's C3H8. If we add in the one double bond, that becomes propene, and we have C3H6. Every time you add in a double bond, you basically remove 2 hydrogens. The same thing for a ring. It removes 2 hydrogens. So if we looked at this, we have 1, 2, 3, 4, 5, 6, 7 double bonds and 3 rings. So how many hydrogens should we be short? So if we have 7 double bonds and 3 rings, that's a total of 10 things. And if each of those is 2 hydrogens, we should be short 20. And so that's how you get C14H10 as well, right? Is we just subtracted 20 of those hydrogens. Right? And so that's going to pretty much do it for today. Right? There are some more practice problems where you guys can go through and name your compounds. I'll put up an answer key for them so that way after you guys have practice, you can kind of do that. You can practice also doing your condensed formulas from it. The line drawings are an important thing to have, but your ACS one is not going to be very many line drawings. Like you're not going to draw them, you just have to interpret them. The same thing for your final. I generally think it's an important ability to be able to draw them. But right now, because there's not really an interface where I can have you guys draw them, then it's really more about being able to interpret them. Right? So you do want to practice both of these, practice with your condensed formulas a little bit, and then I'll put that answer key up. On Wednesday would kind of run a lot of problems similar to what we just did, where you guys will have the ACS questions. We'll go through a bunch of different ones. If there's a specific topic that you would like to get reviewed, then send me an email and I can try to see if I can find any of those type of questions to put in there. And then we'll just kind of just do a lot of practice problems on Wednesday.
So I have a quick question.
Yep.
I was wondering if the final was going to be like more concentrated on the last 2 chapters rather than the older ones.
So it's not necessarily focused on the more recent stuff. I would say that your final is pretty cumulative from throughout. What I would say is things like chapter 20 and chapter 22, the ones where we're really just kind of applying things, those are not quite as important. Those concepts will kind of get grouped in with some of the other topics, right? So similar to like what we did with the acid rain and finding your pH, your question that's dealing with atmospheric chemistry might tie in equilibrium into there. And so that way we can kind of take care of both of those topics in one question. But there definitely will be ice tables to solve. There's going to be KSP. So there's going to be a pretty even spread of the material from the beginning of the class till now.
Gotcha.
Okay.
Thank you.
Mm-hmm. Any other questions? There will be organic on your final. There will be things like naming and your functional groups, things along those lines. There might be questions about the reactions ones. What I would say is generally my approach to studying kind of goes through 2 things. One is I would read through the study guide, right? And I would just star things that I have no idea what was going on, right? So if I go through and the expectation is, you know, this, we can pull up an example of this. Let's say that I'm going through this and it says determine the oxidation number of my metal complex, right? I would star those different expectations that I go down. And if I don't know what it's asking, I would star them, right? From there, I would recommend going to your exams first. Look at your past exams, see how you did, what questions did you struggle with. And for the ones from the beginning, I would also recommend looking at what were the long questions, because you might have known how to do them back then, but you want to make sure you still know how to do them. If it is a long question, so things like titrations and finding your pH at your different equivalence points, that is a concept that clearly I thought was very important. It was on your quiz and on your exam, and it was a big part of your exam. And so that's kind of how I start to piece some of those pieces together. So your past exams is a good one to start. From your exams, I would look at your quizzes. Once I have the topics kind of where I know I'm weaker, then that's when I look back at the slides or I look at the homework. Right? So I wouldn't recommend starting from the homework or the slides as your beginning point and working your way through. I generally recommend look at your study guide first, so that way you can figure out what topics might be like a weaker point for you. Then I would see if those topics show up on your exam or your quizzes. And then from there, I would be looking at your homework to kind of practice those topics. And that's what I would do as I kind of break that down. As you're going through, write down if there's a really good question that shows up, right, that you think is a good way to solve things, or like if there's equations that you really like, or you know, if you're solving a titration problem, things to help you remember what equivalence point looks like, your half equivalence point, where you need to be looking for those things. I would start to write those down on a piece of paper, and then at the end, I would turn those into my note card. And so that's kind of how my approach to study. Does anyone else have any other questions? So the test is going to be similar to what you've been having online. It won't be as many big problems as we normally would have in a like a typical in-person exam. So if you've had me for other finals, there won't be as many multi-part questions, just because of the way that the formatting works. For Canvas, it's trickier to get all those things to line up. And I can only get one type of feedback from you guys at each of those junctions. So I would say that it will be more similar to like your normal exam format, as opposed to like a different final exam you've had from me. If you run out of problems and you just need new things to look for, what I would say is I've been reviewing the ACS Olympiad, the part 2s, and there are some of those in there that I do like, because it is starting to have you guys pull many parts together. And so if you're just bored and looking for something to do, that's what I would recommend, is a good place to find like those longer multi-part questions, or just a little bit more complex questions. That would be a good place to look. Okay, I'll stick around if you guys have any other questions. We can go over that. Otherwise, I will see you guys on Wednesday.